Unit 10, Lesson 3, Trigonometric Functions of Any Angle. We're going to start by determining the exact values of 6 trigonometric functions given a specific angle. In example number 1, we're going to graph the ordered pair -12, -5. So I'm going to go 12 units to the left and drop down 5. Now I'm going to create this angle back to the origin, and this is the angle that I'm going to evaluate. Always creating a right triangle with the x-axis. A big mistake, or common mistake I often see students make, is once they've found this particular point, they sometimes go back to the y-axis. We're always going to rotate back to the x-axis. So I'm going to start by drawing this triangle that I just created, and this is going to be my angle. Now we're going to use this ordered pair in order to identify these lengths. Remember that length is a distance, and distance is always positive. So from the origin, I traveled 12 units to the left, and because it was to the left, that's why you see this negative sign, but distance is positive. I'm not going to write a negative sign. And then I dropped down 5 units. I was told to drop down because it's negative, but the distance is 5. Now I need to figure out what is this missing length. And I can use the Pythagorean theorem. A squared plus b squared equals c squared. Our legs, it doesn't matter which one I identify as the 5 or the 12. So 5 squared plus 12 squared equals some unknown length squared. 25 plus 144 equals c squared, and I add 25 to 144, I end up with a value of 169. Now generally, if I just was doing the algebra and it wasn't specific to this problem, we'd say the answer was plus or minus 13. But because I know I'm describing a length, we're going to leave it at only positive, because again, lengths are always going to be a positive value. Now I can evaluate the 6 trigonometric functions. So the sign is opposite over hypotenuse. Trig functions are just going to be creating a specific ratio, and we're going to follow the directions of sine, cosine, tangent, and then those reciprocals. So again, sine is opposite, the direction is opposite, over hypotenuse. So 5 over 13. We'll come back to the signs of this later on. Then we have the cosine, which is adjacent over hypotenuse, 12 over 13. And then tangent is going to be opposite over adjacent, 5 over 12. Then we have the 3 trig functions that are the secondary ones, or the reciprocals of these primary trig functions. Cosecant, secant, and cotangent. So the reciprocal would be 13 over 5, 13 over 12, and 12 over 5. Now in this quadrant, which is quadrant number 3, remember our acronym, All-Star Trig Class. Only tangent and its reciprocal are going to be positive. So these will remain positive. Everything else needs to have one negative sign inserted. Now that negative sign can be written on top, in the numerator, in the denominator, or out front, but only one can exist. For our second example, let's plot point 2, -4. So 2 to the right and dropping down 4. Remember, we're always going to go from the origin out to that ordered pair and then always back to the x-axis. You may want to write that in your notes with an asterisk. I'm going to recreate this triangle, noting the right angle and the angle that I'm going to be evaluating. We went a distance of 2 to the right and a distance of 4 down. A common mistake is students often want to write -4 in this position. Distances are always positive. How do we identify this third and missing side? Again, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. So 4 plus 16 equals c squared. And now we're going to go back to taking the square root of 20, we should get an answer of plus or minus 20, the square root of 20, but recognizing that this is distance, distance will only ever be positive. At this level of mathematics, I want you to recognize when you're able to simplify. And so here's one I want you to recognize that we can take the square root of 20 and break it down. So what perfect square divides nicely into the square root of 20? That'd be the square root of 4. The square root of 4 is 2, and now we can rewrite the square root of 20 as 2 times the square root of 5. So anytime you're able to achieve a length of a side, and that length is going to be represented as a square root, you always have to see, can you rewrite it in a more simplified fashion? So this is 2 square roots of 5. Let's go ahead and evaluate the 6 trig functions, and then we'll come back and determine what should be the sign of these 6 trig functions, knowing that my ordered pair lands in quadrant 4, all-star trig class, and only the cosines are positive. So actually, you know what, I might as well go ahead and put a positive next to the primary and secondary trig functions for cosine and secant. Everything else will have a final answer that is, in fact, negative. Okay, here we go. So I'm going to create a ratio here for sine. Sine is opposite over adjacent. So I'm going to come down here and write, we have opposite, length 4, over, I said adjacent, and I meant to say hypotenuse. What can I reduce? Well, 4 and 2 reduce to 2 over 1. And so yes, 2 over the square root of 5 is the correct mathematical answer, but we can see it's not in proper form. So negative 2 square roots of 5 over 5. Now, what is the reciprocal of 2 over the square root of 5? It would be square root of 5 over 2. Cosine. Cosine, from this angle, we can see the adjacent is the square root of 2 over the hypotenuse. The 2 and 2 reduce just like the 4 and 2 reduce, and I have 1 over the square root of 5. Not wrong, mathematically correct, but we can write it in more proper form, 1 square roots of 5 over 5. What is the reciprocal for the secant? It would be the square root of 5 over 1, or simply just the square root of 5. Tangent. Yes, it's sine over cosine, but when we think about the ratios created by the lengths of 2 of the 3 sides, we can also look at an angle and simply do opposite over adjacent. So opposite over adjacent would be 4 over 2, which reduces to just 2 over 1, or simply 2. We can see the negative sign because we know it lands in quadrant 4, and the reciprocal would be negative 1/2.